I'm asked to find the doubling time, and the interest rate is 4%, and it says compounded continuously. So that's going to be a PERT problem. There's a shortcut to it. It's just going to be ln of 2 for doubling time over the rate as a decimal, 0.04. So this one we just type into the Casio, ln2 over 0.04, and 17.3 is the answer. And that is correct. Is the function 1 to 1? First, it's a function, so it passes the vertical line test. But in order to be a 1 to 1 function, it has to also pass the horizontal line test. And this one passes both. So yes, it is a 1 to 1 function. For number 3, it asks if this is a 1 to 1 function. So first off, it's a function. It passes the vertical line test. But notice down here, it fails the horizontal line test. The horizontal line hits the curve 2 times. As well up here also, it hits the curve 2 times. So no, it is not a 1 to 1 function. Number 4 wants to know if this is a 1 to 1 function. Notice how it's something squared. So if I were to graph this, it would be y equals something squared. And x squared looks like that. That's the end behavior. So anything that's an even function is going to fail the horizontal line test. So this one is no. That wants to know if this is an inverse of this. So first thing I'm going to do is copy down this equation as y equals 5x minus 6. Then I'm going to flip-flop the x and the y, so x equals 5y minus 6. And I'm going to solve this for the y value. So I'm going to add 6 to both sides. That's going to give me x plus 6 equals 5y. Then I'm going to divide both sides by 5. And notice, the fancy notation would be f inverse of x would equal x plus 6 over 5. Notice they tried to trick me. They flip-flopped the 5 and the 6. So the answer to this is no, they are not inverses of one another. For number 6, I'm going to do the same process. Y equals 5x minus 5. I'm going to flip-flop the x and the y. X equals 5y minus 5. I'm going to add 5 to both sides. It's going to give me x plus 5 equals 5y. Then I'm going to divide every item by 5 and see what that gives me. Notice that'll be 1/5 x plus 1. So yes, these are inverses of one another. Is this a 1 to 1 function? That's a line, y equals 6x plus 4. So if I were to graph it, notice I'd begin at 4 and the slope would be positive. And it passes the vertical line test and the horizontal line test. So it is 1 to 1. Next, I'm going to have to find the inverse of it. So I'm going to rewrite it as y equals 6x plus 4. Flip-flop the x and y, so x equals 6y plus 4. Subtract 4 from both sides. X minus 4 equals 6y. Divide both sides by 6. So that's going to give me x minus 4 over 6, and it should be choice B in this scenario. This one is just a calculator key in, so I'm going to take 1/5 and raise it to the negative 2 power. So I'm just going to type in parentheses, fraction bar 1/5, and raise that to the negative 2 power. And it'll give me a 25, and that's it. Just a plug-in. Now they want me to raise 1/3 to the 5 halves. So they want me to take 1/3 and raise it to the 5 halves power. Again, another calculator key in. Whoops. Parentheses 1 divided by 3 to the 5 over 2. 0.064. 0.064. Again, just a simple calculator key in. Graph the function. Well, 5 to the x would look like this. 5 to the negative x would be dk. So let's see if that's on one of our choices on the other page. Oh, it got kicked out. The choice got cut off, so it would actually look like this. It would creep down, go through 0, 1, and then hover along. So I don't know what choice that is, but that's what the graph would look like. Number 11. 3 to the x would look like this. But then because it's minus 4, it would slide it right 4. It would have to be choice B. It wouldn't go left 4. It's opposite and then the same outside. This one would go down 4. So 4 to the x would grow upwards, and then the whole thing would be shifted down 4. So the actual answer would look like this. Instead of going through at 0, 1, it would go down 4 units and be like that. And there would be a horizontal asymptote at y equals negative 3. I'm sorry, it goes down 3. This one, we're going to use the log base button. So the base is 81, that would go inside that box. The argument is 3, and that would equal x. So this again is a calculator key. I'm going to hit that wonderful button right over here and type in the 81 for the base, and then the 3 for the argument. Log base 81 of 3 equals 1/4. If you can recognize those, it goes pretty quickly. Another log problem. The base is 1/8, the argument is 64, so it's going to be log base of something equals x. The base is 1/8, and the 64 is the argument. Again, another calculator key in. Log base 1/8 of 64, and I get negative 2 as my answer. This one's a little tricky because the exponent is negative, so I'm going to do log base, again, of 5, of 1 over 25, and then whatever my answer is, I'm going to change the sign, because this equals negative x. So I'm going to type that in the calculator. I'm going to hit my log base button, of 5, of 1/25. Hit equals. Now it says this answer is negative 2, but negative 2 equals negative x, so the answer is actually going to be 2. Another log base button. So log base, the base is 3, the argument is 1 over 81, but this is going to be a little tricky. That is going to actually equal 2 minus 3x. So I have to solve it a little bit after I type this in. So I'm going to type in log base 3 of 1 over 81 negative 4. So this whole left side equals negative 4 equals 2 minus 3x. Subtract 2 from both sides. Negative 6 equals negative 3x. Divide both sides by negative 3. So my answer is going to be x equals 2. This one's a little tricky. What I would do is I would throw in the answers, because sometimes 2 answers work instead of just 1. So let's see. They're going to say a equals 2. So 2 to the 3 halves. Let's see if that equals 8. So 2 x box to the 3 divided by 2. That doesn't equal 8, so it can't be choice A. Now let's try negative 2. Notice how I tried 2. Well, it can't be B because 2 didn't work. So now we're going to try C. Negative 4 and 4 and just plain 4. So I'm going to clear this out and do a parentheses. Negative 4 to the 3 halves. Doesn't work. So that means negative 4 is not an answer. Let's try just plain 4. So I'm going to go back and delete that negative. And yes, 4 to the 3 halves does equal 8. So the answer choice is going to be D. Solve the equation. For this one, we're going to have to rewrite this as 2 to the 4th times some quantity equals 2 to the 5th times some quantity. And that's going to be x minus 2 goes into this exponent, and 4x goes into this exponent. So now I can ignore the 2's, and that's going to give me 4x minus 8 equals 20x. I subtract 4x from both sides. Negative 8 equals 16x. Divide both sides by 16. My answer is negative 1/2. You could have also went and plugged each of these answers into the equation for x and see if the left side equaled the right side. You could have plugged and shoved. Find the future value of 21,000 for 3 years, compounded semi-annually. This is a print problem. And my principal is 21,188. My interest rate is 0.07 as a decimal. The number of compounding semi-annually is 2, and the amount of time it's left in for it is 3 years. So my formula is going to be A, the future, equals the principal, 1 plus r over n raised to the nth power. My principal is 21,188. 1 plus a fraction bar. The fraction is going to be 0.07 over 2. And the exponent is going to be 2 times 3. I can do that arithmetic in my head. That will be raised to the 6th power. Can't do this one without the scientific calculator. 2, 1, 1, 8, 8, parentheses, 1 plus the fraction bar. On top of the fraction bar is 0.07, down arrow, 2, right arrow, close parentheses, raise it to the 6th power. And let's see if it lines up with our choices. $26,045.46, but they have us rounded to the nearest dollar. Find the future value again. Once again, it's a print problem. The future value is 1789. The interest rate as a decimal, remember I moved that decimal 2 places to the left, is 0.062. Compounded quarterly, so n equals 4. The amount of time it's left in is 12. Same formula, the future amount equals the principal times 1 plus the rate divided by the number of compoundings to the number of compoundings times the number of years. 1 plus a fraction bar to an exponent. The fraction bar is going to be 0.062 over 4, raised to 4 times 12. I believe that is 48. Calculator can. 1789, open parentheses, 1 plus fraction bar, 0.062 over 4, n equals 4, raised to the 48th power. 3743.23, and it lines up perfectly with choice D. Doesn't get any better than this. Just hit the log base button and fill in the blanks. Log base 9 of 729, hit equals, the answer is 3. This one is almost, oh, they want us to write it. They want us to write it, they don't want us to evaluate it. So again, I'm going to use the log base of an argument equals something. So notice the base is 4, the argument is 32, and it's going to equal 5 halves. And you can test this. If you type in log base 4 of 32, log base 4 of 32, you'll notice it equals 5 halves. If you type this in, it won't equal 5 halves. So if we typed in log base 32 of 4, it's not a true statement. It's 2/5. If we type this in, it wouldn't equal 4. If we type this in, again, it would not equal 5 halves. Write the equivalent expression in exponential form. The log leg kicks the 4, the 4 flies over and kicks up the 1/2, so that's going to give me 2 equals 4 to the 1/2. Or 4 to the 1/2 equals 2. Again, another calculator can. So I'm going to hit the log base button, type in 2 for the base, 1 over 64 for the argument, and equals negative 6. The log leg kicks the 3, the 3 flies over and pushes up to negative 2, so I'm going to evaluate 3 to the negative 2. And see what the calculator kicks out. 1/9. Choice B. Graph the function. A log function usually goes through 1, 0, creeps up along the x-axis, the y-axis, and goes through 1, 0. This is going to be shifted right to. Again, I don't have enough of the graphs here. The computer didn't print it out. So it would be that graph, that picture, shifted right, 1, 2, and it would have a vertical asymptote at x equals 2. And it would look like that. This one is another log, but it goes up 4. Notice it isn't trapped in parentheses, so it's going to be a log that goes through 1, 0, and then this whole graph is shifted up 4. So the actual curve would go through, instead of 1, 0, that would go up 1, 2, 3, 4. It'd still have a vertical asymptote of the y-axis, but it would go through 1, 4 this time. 1, 2, 3, 4. Log base 6 of x is just going to be a. It just looks like this. Goes through 1, 0, creeps up and goes through. This one is a trick question. They want me to rewrite it, but you can't. You can't break down a positive when it's in this form. So the answer is the question. You can't break it down. Expanding a logarithm. Notice I have 1, 2, 3 items, so I'm going to write the word log 3 times. Log, log, log. Base 7, base 7, base 7. 10xy. If it's on top, it gets a plus sign in front. If it's on top, it gets a plus sign in front. If it's on the bottom, it gets a minus sign in front. The 10 stays as it is, the square root x. Remember, I can rewrite that as x to the 1/2, but the 1/2 gets ripped out in front when I write a log. So instead of putting 1/2 up here, it actually goes out in front of the word log. And the y is where it is, so it's going to be positive log base 7 of 10. It can't be c. Plus 1/2. This is a trick question, it isn't that. This is multiply, it can't be that one. It's going to be choice B. It breaks multiplication down to addition. It breaks division down to subtraction. It breaks the square root down to a fraction. They want me to rewrite this as a single logarithm, so they want me to condense it. So I have 1, 2, 3 items, but it's just going to be log base A. I have a minus sign, so that means there's going to be a division bar. The log base A of m is a positive, so the m is going to go on top. The k is going to go on top, but it's going to be k to the 4th. That gets thrown back up there. And the n is on bottom because it has a negative in front of it. And there's the answer. Asked to write as a single logarithm or condense it. So I have two terms, an x and a p. But notice the minus sign, so I'm going to write the word log base A and a division bar. And because it's a positive 9 log base A of x, the x goes on top and the p goes on the bottom. Now notice, there's a 9 out in front, so that 9 is going to get dragged upstairs. So it's going to be x to the 9th. Notice the 4 is going to get dragged upstairs, but 4 times 2 is 8, so that's going to be p to the 8th power. So log base A of x to the 9th over p to the 8th. And that's choice A. Number 23. Now notice it doesn't have anything underneath the log, so you're not going to hit the log base button. You're not going to hit the log base button. You're just going to hit the plain log button, and then you're going to type in 2419. And it'll round it out for you. There you go. 3.38 says to 4 decimal places. So 1, 2, 3, 4. Now I have to look to the spot, the 5th one. If that's 5 or above, I give this a shove. If it's 4 or below, I let that go. So it's going to be 3836. 3836, choice C. Another calculator key in. 4 decimal places. So now we're just going to hit the LN button. Just the LN button. LN of 269. 5.594. And that one they went to 4 decimal places. So 1, 2, 3, 4. That's 4 or below, so I let that 7 go. I leave that as a 7. So it's choice A. They tell me to use the change of base rule. I don't have to. I can just type that in using the log base button. Log base 2 of 6. 2.5849. This one's a little tricky. Because the 6 is 5 or above, I give the 9 a shove. That's going to make that 10. So it's going to make that 4 or 5. So it's going to be 5850. 5850. Choice B. Another log base button. Going to hit the log base button of 7. Right arrow of 2.6. 0.4910. 0.4910. Solve the equation. So this is going to be a log base button. The base is 5, the argument is 21, and the answer is going to be x. So log base 5 of 21. Log base 5 of 21. 1.89, 1.8916. They want me to round it to the nearest thousand. That's 3, so that's going to be a 2 there. 892. So it's choice C. Similar problem. This time they want me to do log base 5 of 22. So again, it's going to be a log, a base, an argument equals the answer of x. The exponent is the answer in this case. So I put the base of 5 down here. I put the argument of 22, and I type it in. 1.921. Notice they want me to round to the nearest thousandth, so that's 5 or above. I give that 0 a shove. I make that a 1, so it's 921. Choice A. Solve the equation. First thing I'm going to do is I'm going to divide both sides by 5. That's going to give me e to the 5x plus 6 equals 5. Now I'm going to ln both sides to get rid of the e. When I ln the e, it cancels out. So that's going to give me 5x plus 6 equals ln of 5. I'm going to type in ln of 5. Hit equals. So this side is 1.6. Then I'm going to minus 6 from both sides. So while that's still in my calculator, I'm going to hit minus 6. So 5x equals negative 4.39. 5x equals negative 4.39. So now I'm going to divide both sides by 5. So while that's still in my calculator, I'm going to hit divide by 5. 0.878. Negative 0.878. Choice A.